Hi. Hello. We'll wait a few minutes. I started the wrong classroom at first. Hi. Good morning. Hello. Do you have the link for the remote check-in forms? Okay. Can everyone hear me okay? Okay.
Where's the remote learning one?
I can post it. Let me do that. You see it? Posted now? Might a refresh. Okay. Well, while we wait for Noah and Mac and Macy, you might be interested in this, John. I don't know if anybody else will be. I'll share my screen real quick. This is just an aside. Do you see this nasf.org site? If you go to compete, you'll see that there is a kind of a Rocket League thing that's going to start up eventually. But also under events, it looks like there are one-day tournaments for Smash Brothers going on. I guess Valorant's next weekend, but then they got some more Smash. So if you're interested, check it out. Well, how are you guys today? How are you holding up?
Pretty good. I mean, e-learning's not too bad. So that's good.
At least you get some breaks. That's the nice thing. So let me know if you guys are having trouble. We're eventually going to move into a test. So we're going to just study now for that. Kind of go over the homework. Remember, the homeworks have been extended. The questions will be like from the homework. So we'll go over some of those again together. And I'm going to show you some of the next topic. These questions won't directly be on the test, but I think they might help you conceptually get what we're doing. So we have basic quadratic equations where you just kind of like square root both sides. You get plus or minus on one of the sides, and then you just isolate the variable x. So you kind of just square rooting on everything and just making sure you know the steps that you need to take to do that. The quadratic formula, you just sort of get things into the correct form. Some number times x squared, then some number times b times x, and then some number without x. And you kind of just plug the number on x squared in for a, the number on x in for b, and the number that's alone in for c. And you just plug things into the formula, and you work that out. Well, Noah? So that one's just a formula. The formula works always, like you can always just use the formula. Factoring is kind of the same thing as using the quadratic formula. You could always just use the quadratic formula to do these things. But factoring is a way that you can do it without using the formula. If you go on to college algebra, they will kind of expect you to know how to do that. So it'd be good if you did have at least exposure and experience with that. There is something I should talk about before we get started. I'll keep completing the square off of this test. I may push back that date so that you can do that later. If you've already done it, great, you're getting ahead. But I'm going to go over polynomials 1 with you, and maybe we'll do that kind of together today if we have the time. We might not finish it, but I think it will help you conceptually kind of get the strategy of the algorithm or what we're trying to do, symbolically. And then after this, we'll get to some applications and maybe some projects. There'll be some things that we could do on a test, but there'll be some things that'll just kind of be project-based, and I just need to see evidence that you're learning from that, and so you'll get credit in a way other than a test, coming up soon, but not quite there yet. So one thing I guess I should mention is that let me see if I can come up with college algebra topics. So a lot of you, if you're planning on going on to college, well, I just need to see a list of topics, really. So a lot of you will need college algebra if you go on to college, and even if you're not planning on going into math, if you want to do something that involves a 4-year degree, a lot of subjects do require college algebra. And a lot of students get stuck in college algebra. They don't pass it. Then they fall into like remedial classes. And then, well, that would mean you would be taking classes that you're paying for and you're not getting college credit for it. And it could take a lot of time. So college algebra is kind of a hurdle for a lot of people, even if you're just going to play sports or something. You might have to take college algebra and pass it. So that's something we're really wanting you to succeed at if that's where you're going. You may not have to do that if you're going into some vocation or some technical trade. You wouldn't need college algebra. There may be some programs where you could get by with a liberal arts math. But one thing to know about college is that it'll expect you to do all these things in one semester. And it's going to be very test-based. So, you know, we're concerned about your preparedness for that. So especially if you're a junior, we're thinking about offering an extra course next semester. And we'll get a Google form out to you guys so that you guys can kind of vote. There's different pathways that we can go down, depending on what you would look for. There's something called transitional math, which the state of Illinois is now implementing for all schools. That there's a class you can take, which will called quantitative literacy, which would guarantee you, if you pass it, placement into a statistics course like the one I teach here. If you can do the statistics course here, get in and take it, then you get college credit for it, so you wouldn't need that class. There's another class which is called STEM, Transitional Math STEM. It's really aimed, it's not just STEM. Even like if you want to be a teacher or something, you would have to take, that'd be good for you. You'd need to take college algebra. I'm not sure about nursing, if they need college algebra. But a lot more professions than you might know do require college algebra. The STEM course really tries to teach math in a different way. I don't think it'll cover as many topics. It's rather than a mile wide and an inch deep, it's supposed to be deeper, but it doesn't cover as much. So that's a transitional math course, which if you pass that one, would guarantee you placement in Illinois state colleges. It would guarantee you placement into college algebra. So you wouldn't have to go in and take a placement exam. And if you don't do well enough, you don't even get into college algebra. You have to take a remedial course. And some people get stuck there. We could offer that. Otherwise, what we could do is do a kind of like a pre-calc light. Pre-calc is kind of like college algebra. But it would be long. You'd have more time. It'd go at a slower pace, and it would kind of just build on Algebra 2. And it would feel more like what we expect college algebra to be like. So the idea would be that it might help you better prepare, give you something to do with your senior year that isn't like consumer math or something that might actually prepare you for succeeding at college algebra. So we have these different options. It's really the transitional math versus the what we're kind of calling pre-college algebra or college algebra prep. So depending on where you think you're going and what you think you'll need, it might be good to look at colleges that you're thinking about, look at the programs. You can go to a college's course catalog, look at the program, see what the requirements are, how many credit hours, how many natural sciences, how many humanities, how many whatever, and see if they require college algebra. And if they do, there's a couple options for the kind of course that we could offer for people in their senior year, so that they don't just kind of end Algebra 2, take a year off from math, and then get thrown into the mix, because it moves much faster in college, and it's less forgiving. So just watch for that. I'll get that form out to you soon. But here's kind of the list of topics. So they'll go over the introduction to algebra. They'll go over all the numbers, how to work with numbers, and how to do that symbolically. So instead of working with numbers, you're working with letters, but it's all based on the properties of numbers. You'll need to be able to solve basic equations and inequalities. We haven't done a lot with inequalities. They'll go over linear equations, lines, functions, and graphs. So you'd have to know function notation, slope, intercept form, the different forms of a line, modeling things with line, finding the line that goes through a certain point that has this slope, problems like that. We've done those. We're going to get into sequences before the year's over. We haven't covered that yet. Systems of equations, we did do some systems. So you guys did systems of linear equations, where you have two equations with two variables, and you had the substitution method, you had the elimination method. So you've seen some of that. Then, yeah, they'll do inequalities too. So not just solving equalities, but inequalities. You'll have to know a lot about functions. That's a big chunk of it. So all the transformations of functions that we've covered, you'd have to be good with that. You'd have to be good with the a lot of different families of functions. We haven't covered all of them yet, and I'm not sure how far we'll get. Absolute values, quadratic equations and functions, which we're sort of working on right now. Polynomials, which we will look at briefly next, but it's a huge topic. And then there's exponentials and log. That's a different type of family. There's radical equations, rational expressions, periodic, trigonometric functions, working with complex numbers. So, I mean, the list goes on. So it's a lot. So you might want to start thinking about, what you want to do after this, and what would be, what do you need, and do you need to spend more time building on algebra to be ready for college algebra, should you need it? So that's just something to think about. I'll get that questionnaire out to you soon. Anyway, so I wanted to go over polynomials, start that with you. Quadratics and even lines, they are polynomials, or they are functions, polynomial functions. So this is just kind of a conceptual one, but I think it'll help you understand kind of what we're trying to do with quadratics. Quadratics are sort of the simpler polynomials, and once you understand quadratics, you can build the other polynomials on top of that. So I want to go through some of those. All right, so a polynomial is just, it can be expressed as in what's called standard form, where you have, basically powers of x in combination, like added or subtracted. This is like a vocab one. The degree of the polynomial, the leading coefficient, what we call the leading term, those basically just, you look at the highest power of x which in this case is 7. And this would be the leading term. And usually we put them in order, descending order, so that we start with the big one. So we call it the leading term when it's in standard form. The degree of the polynomial is just the number up on the highest power, so 7. So the degree of this polynomial is 7. Is that okay? The leading coefficient, well, we call this the leading term, and the coefficient is just the number that multiplies the power of x. So the leading coefficient in this case is -3. Now, with polynomials, the maximum number of real zeros, that's basically the same as the degree. So polynomials kind of, they bend like sort of, they're just like sort of squiggles, and they can do all sorts of things like that. And if you think about them going around the horizontal axis, it's just how many intersections with the horizontal axis are they capable of. In maximum, a 7th degree polynomial would be capable of crossing the horizontal axis 7 times. So that should also be 7. Is this okay so far? Okay, so it's just looking at the polynomial and knowing, okay, that's the highest power is 7. So it bends, it changes direction 6 times. So the changes that we call the turning points, there'll be 1 less than the power at max. So if it's 7, it means it'll change directions once, twice, 3 times, 4, 5, and then 6. So it has 6 bends, up to 6 bends, and it can cross a flat line up to 7 times. Because it crosses it once, twice, 3, 4, 5, 6, and then last time 7. 7's kind of a big one. I should have started with a smaller one. All right. The next question gives you a polynomial. This is a 3rd degree polynomial. You can see that it bends twice. It turns around twice, once, twice. It has 3 intersections. And this one says, at what value of x as the input to the function do you get an output that equals 8? So the output is the vertical part. So if I just go up 8, I just find where it crosses. And these ones are a little annoying. I think they'll let you get close, like within, just get as close as you can. You might have to click this thing. But at 8, it looks like that's where it intersects. So that's just before 3, maybe 2.9, 2.8. So that's all you have to do for that one. Just where does it reach 8 vertically when the output is 8? Because the vertical is the output. The horizontal numbers are the inputs. So let's see what they say. Yeah, 2.9. I think if you get within a small amount, it'll take it. This one, here's a polynomial, 3rd degree again. You can see it has 2 bends. Where does it equal -10? What value of x makes it -10? So I'm just going to go down 10 and figure out where that happens. It looks like at -3 it hits -10. So the x would be -3, the y would be -10. So yeah, -3. Is that okay so far? It's just getting familiar with it at this point. It shouldn't be really hard. It's just stuff you're going to have to remember about the way it works. Okay, the number of zeros. Well, zeros are where the height is 0. So that's where it crosses the horizontal axis. Now you can have a 0 wherever it crosses. And you can have the same 0 multiple times. And that's called the multiplicity of the 0. So how many multiple times do you have that 0? And the idea here is that if it just goes straight through, that's 1 0. So I have a 0 at 6. So a 6 is my 0. And the multiplicity would be 1. Here I go through 1. So that's a 0. And again, it goes straight through without any funny business. So that's a multiplicity of 1. I have 1 of those. Then it looks like it doesn't go straight through at -6. It comes in at a flat angle, but it does go through -6. But it does it not hard. It kind of barely graces it and then goes through. That's a multiplicity of 3. So -6 is 0 and the multiplicity is 3. So the way the multiplicities work is if you have a multiplicity of 2, it'll kind of do this. It'll flatten out. It'll touch at that 0, but it'll look like a parabola. It'll come back. It'll touch, but it won't pass through if you have a multiplicity of 2. But if it does that, kind of like a parabola, but then it does go through, then it's 3. So 1 is just straight through like a line. 2 is just barely touching it like a parabola. And 3 is kind of coming in flat, going through, and then actually going through, but does it in a sort of flattened out way. You can have multiplices of 4. That'll kind of be like the parabola, but the bottom will be flatter. Like it'll be even flatter than a parabola. So that's how that works. And you can see that we have -6 has a multiplicity of 3, 1 has a multiplicity of 1, and 6 has a multiplicity of 1. So you can have a 0, but you can also have a 0 multiple times. And if you know what those are, you kind of already know what the graph looks like. You can really think of the parts of the parabola as really describing the graph, and vice versa. So you can look at the graph and figure out these things, or you could figure out these things and kind of know what the graph looks like. Here's another one. So I have a 0 here at -4. What do you think the multiplicity is? Since it goes straight through.
1.
Yeah, good. Here I have a 0 at 0 itself, but it kind of looks like a parabola. It touches, but it doesn't go through. So what would that one be? Not sure. So straight through is 1. Touch.
Is it 3?
Could you say it again?
3?
Not 3.
-3? I don't know.
It's 2. It's 2. And then here you have a 0 at 5. It kind of is starting to look kind of like a parabola, but it actually goes through. So what would that one be? It's not good. So that's how you do those problems. Questions about that? All right. We're not going to do all of these right now, but just the ones that I think would kind of help you understand what we're working on right now. All right, so you can write these. So they want us to write a formula in this case. I'll just show you the answer. Now this part's a little extra. This one's a little complicated right here. But you have a polynomial of degree 3. that means you're going to have 3 linear factors. Take them as something squared or something cubed. That's the multiplicity. So this factor has a multiplicity of 2. It's for the same thing, but their solutions, zeros, and roots all mean the same thing. That's these things. That's the crossing points. You could call them zeros. You can call them roots. You can call them solutions. The polynomial, this one has degree 3, so it's going to have 3 linear factors. You can see that it crosses, it has a root of multiplicity 2, means you have 2 of them, at x equals 5. Well, if I write, like, I'm just going to type this, x equals 5. Well, I don't need the parenthesis. Well, I guess it's putting it in there for me. So if I have x equals 5, well, I want a 0. I want something where it goes to 0. So if I subtract 5 from both sides, that'll give me x minus 5 equals 0. So the solution, or the root, where it crosses 5, turns into a factor where you have x minus 5. So it kind of flips the sign when you put it on the same side of the equation. So if I have a root, if it crosses at 5, my linear factor, when I write it as a formula like this, would be x minus 5. You just flip the sign. I have 2 of them, so I could write it twice. I could write x minus 5 times x minus 5, or I could just put a power on it to show that I have it times itself twice. And then I have a root. I have 1 of them, multiplicity 1, at x minus 3. So I flip the sign and I write x plus 3. That's one of my factors. Now this is a little extra. Maybe I won't explain this bit just yet. So we'll come back to this when we get to it. But just trying to get you to associate now not only the roots with the graph, but also the factors and the way the function looks in factored form with the graph. So if I had this thing, ignore the front part, but if I had x minus 5 times squared plus x plus 3, that means it would cross at x minus 3. It would go straight through because I have it once. And then at plus 5, it would kind of do a parabola. It would just touch and turn around. The power is the multiplicity. The opposite of the number is the root, is the 0. So you can do it this way. You can write it as a function. It's just a little different, but it works the same. Okay, degree 3 polynomial. So I'm going to have 3 linear factors. Having zeros at -1, 1, and 8. And the coefficient of x cubed equals 1. That part means the coefficient just means you don't really have a number out front like this. So it just makes it easier. Okay, so I'm going to have 3 linear factors. I'm going to put an x in them. And if I have a 0 at -1, I'm just going to flip that sign, and I'm going to put a plus 1 in. That's one of my factors. If I have one at 1, then I flip the sign, and I can put a -1. And if it crosses at 8, then I can put in a -8. And that would be my answer. So where it crosses, straight through, you have one of those, and you just flip the sign on the number and put it in with x in the linear factor. And so if I saw this graph, I would know it would kind of cross at -1, cross at 1, and then kind of go out and cross at 8. Okay. This graph, they want to know what is the least possible degree of the polynomial graphed above. So how many turnarounds, how many turning points do you see where it changes direction? Well, we see 1, 2, 3. So that would be a 4. That'd be degree 4. It's always one more than the number of turning points. If I draw a straight line through this, the maximum number of points I could hit is 1, 2, 3, 4. That's another way that you can tell. All right, here, what's the least degree possible for this polynomial graph? Well, it turns around once, twice, 3, 4 times. So what would my degree be?
5.
Yeah, good. It's not too bad, right? I hope. All right, then we got another one of these. Do you guys know? Now they're not in order, but what's the degree of this one? Now this one's written not in factored form, but in standard form.
7.
Yes. Leading coefficient.
-4.
Yes. And now the constant term. Do you know what that means?
No, not really.
It's the term that doesn't have a variable on it. You know, the variable varies, makes the term change as you move along the graph. But you have one term that doesn't change. It doesn't depend on x. Does that help you?
Yeah.
What do you think it is?
3.
Yeah, good. So that's just kind of like a vocab one. We'll do one more of those. Degree. Anybody? What would be the degree of this one? People commenting.
Is it 6 or 7?
Everything good? Of course. But that's the summer thing.
Ash, I know
Okay,
what I said
so-
after you told me, okay? We're good. Summer's done.
And then is it x?
Hey, either of you seen some more?
You're on mute.
Now can you hear me? Okay, we lost our connection temporarily. That's been happening this week. I don't know why. I will present again. try this one actually. All right, remember, these represent the crossing points of the graph, but you got to flip the sign to find where they cross. So which one of these graphs, A, B, C, or D, would you say represents this function?
Is it?
Did you say A?
Yeah.
Yeah, it is. Yeah. Good. Yeah, because it crosses at -2, -3, and -4. Good, good. Okay, this one, flip the sign again. So it's going to cross at 2, right? I'm sorry, -2. But at 1, it's just going to touch it and turn around. So A, B, C, or D. So it cross at -2. So this one touches at -2, but this one crosses. And then at +1, it has a multiplicity of 2. So that means it's going to touch it and bounce back. So it's this one, C. This one has a multiplicity of 3 at 4. So that's going to be, like we said, when you have a multiplicity of 3, it goes flat, but it does actually cross through. So that's that one. So this is another way of writing a 0 at 4 with multiplicity 3. All right, so in the remaining couple minutes, what do you need help with on the assignments? What do you like to start with? Maybe factoring? That sound okay? Okay, -1, -30. It doesn't matter what the letter is. If they use Z, just use Z. If they use T, use T. They like to be tricky. Squared. Okay, they may want you to factor on some of these questions. Factoring 1 shouldn't be too bad. It should be pretty straightforward. The trick is you need to come up with 2 numbers that multiply to -30. Maybe I'll make these different colors. But add to -1. So I need 2 numbers that multiply to 30 that are just 1 away from each other.
Would it be -30 and 1?
No, because they're 29 units apart. So I need 2 numbers that multiply to 30 that are just 1 apart. You gotta remember your multiplication tables.
6 and 5.
Good, yeah. So they gotta make a -30. So I have 6 and 5. But one of them has to be negative in order for the product to be negative. I'm gonna make the 6 negative because when I add them, they need to add to -1. So they multiply to the negative 30, but they add to the negative 1. So it's negative 6 and 5. And so I would write it like this. That's how you factor something in standard form and put it into factored form. And now I know that this graph will be a parabola that crosses at 6 and at negative 5. All right.
We do number 6
Number 6.
if it's the same. Yeah.
Yeah, sure, yeah. So, well, do you have a version of it?
Yes.
You want to just read your version to me?
Yeah. Solve the equation C2, c to the second, equals 7c minus 6.
Okay. They want you to solve it?
Yes.
Okay, so to solve it, we have to factor it. The first step in that for this kind of a problem is to get everything onto the same side. And you usually want your c squared to be positive. So I'm going to subtract 7c from both sides. That would give me c squared minus 7c equals minus 6. That's my first step. Then I'm going to add 6 to both sides. And I get c squared minus 7c plus 6 equals 0. Is that okay so far?
Yes.
All right, now we want to factor it. So we're going to get it like we need two numbers that multiply to 6, but when I add them, I get 7. What's a pair of numbers that multiply to make 6, but when I add those numbers, I get 7?
6 and 1.
Good, yeah. Now, I have a positive 6, but when I add them, I get negative 7. So if I make them both negative, they will multiply, the two negatives will cancel when they multiply, and they will make positive 6. But when I add negative 6 and negative 1, I'll get negative 7. So factored, I'll have c minus 6 and c minus 1. So I factored it. To get the solutions or to get the zeros, remember you just flip the sign on the numbers in the factors. So it's going to be 6 and 1. The reason for that is if you have two numbers multiplied and they make 0, well, that works when either this number is 0 or when this number is 0. So if I put c as 6, 6 minus 6 makes 0. Anything times 0 is 0. So that's a solution. You can just set each one to 0 and solve for c. If I put in 1 for c, I'll get 1 minus 6 makes negative 5 over here. But 1 minus 1 makes 0, and negative 5 times 0 is 0. So if I just set, that equals 0 and solve for c, oh, that's a 1. So your two solutions will be 6 and 1. So first get everything onto the same side. Keep the c squared positive. Factor it using this method. And then if they just want the factored form, you can just put this. But if they want the roots or the solutions or the zeros, you flip the sign on these numbers. Is that okay?
Yes.
Okay, well, I think that's good. We'll continue this next class. Keep trying with the homework. I hope you guys are surviving, keeping sane. And I can let you guys go.
Are you doing the office hours thing?
Yes.
Do we need a code?
Yeah, just email me and let me know that you want to do that.
Okay.
And I can create a meeting.
Okay.
Anybody else need to do that? Okay. Well, you guys have a good day.